Hello and welcome to our Chapter 6 notes on fractions. Today we will be doing a little bit of a review. We call this 6.0a because we'll be looking at what is a fraction, what's the difference between proper, improper, and mixed numbers, and then for 6.0b we'll look at adding fractions and subtracting fractions. Then we get into what our textbook teaches us from 6.1, multiplying and then dividing. So let's get started. A fraction, we see, is just part of a whole. So if you say, hey, it's Thanksgiving coming up, I want a fraction of that pumpkin pie, you just want a piece of that pumpkin pie. Sometimes your fraction might be a bigger piece, or sometimes you want a smaller piece. So we call the whole pie, or in this case, the whole hexagon, one unit. Here we have red trapezoids. We have two of them come together to complete one. So each of these pieces here would be considered half. Then with our blue parallelograms, each piece we have three. So this parallelogram is one of the three, so we call that a third of the whole. And we have 6 green triangles here, can go into one hexagon. So we call this one triangle 1 out of 6, because there are 6 here. So this would be 1/6. So we can summarize this below. As you can see, another fancy way of saying 1, you could make a whole number into a fraction by having the same number in the numerator as in the denominator. So anytime you have the same number in the numerator on top as the denominator in the bottom, it's equal to 1. So if you go back into the colors on your first page, you'll see that triangles are the green triangles, and 6 of them make a whole hexagon. So one triangle out of 6 possible triangles make a full hexagon. What fraction of a hexagon is covered by 3 triangles? Well, if we put 3 triangles together, that is half of our hexagon here. So we could say half, or we know that each triangle is 1/6, so 1/6, 2/6, 3/6 of the triangle. So those are 2 ways that you can say that. These are called equivalent fractions. So they mean the same thing, just one is in smaller numbers than the other one. Because we can divide both of these by 3. 3 goes into 3 and 1 time, and 3 goes into 6 2 times. What fraction of a hexagon do 2 parallelograms cover? So if we have two parallelograms, that is 2 out of a possible 3 that can cover a hexagon there. And how many triangles are needed to cover 2 parallelograms? Well, we can divide these in half, so 4 triangles would be needed. Use your pattern blocks to build the following fractions. Draw the shapes in the space provided. Model, please, 2 out of 3, or 2/3, using parallelograms and triangles. So we can say, okay, well, this is 1/3, and this is 2/3 with parallelograms. We could make 2 triangles here to make a parallelogram. So those 2. Oh, and I also saw some people do it like this, with 4 triangles. Those would be 3 different ways to model 2/3 using parallelograms and triangles. Model 1.5 without using trapezoids. Oh, so we could say, well, we could use 1 hexagon. That would be our 1 part. And then a half, we can't use the red trapezoids. So another way to model half would be those 3 triangles. So there we go, 1.5. Model 4/3 in 2 ways. Oh, so this is tricky because now our numerator, the 4, is a bigger number than our denominator, the 3. So we're going to learn how to change this into a mixed number. For now, I'll tell you that our mixed number is 1 and 1/3. So we could show 1 as the hexagon, and then we could show parallelogram as our 1/3, or maybe we could use the trapezoids. 1, and we could even use our triangles to show 1/3. How would you use the shapes to show that the following statements are true? Draw your blocks in the space provided. So we could say 1/2, say with a trapezoid, is the same as 3 out of 6 with our triangles. We could say that 1/3 with a parallelogram looks very similar to 2 out of 6 triangles. Oopsies. And 4 triangles, 4 out of 6, looks very similar to 2 parallelograms. So we see that these here are equivalent fractions. So they're just different numbers to express the same amount. All right, so let's get these definitions down on paper here. A proper fraction is just a fraction where the denominator is larger than the numerator. So you can write this down, a fraction where the denominator is larger than the numerator. A great example, classic, is 1/2. The numerator being our top number 1 and the denominator being the bottom number 2. An improper fraction then, if we have this one's proper, this one's improper, it's the opposite. It's where the numerator is now larger than the denominator. Or we could say it as a fraction where the denominator is smaller than the numerator. A fraction where the denominator, the bottom number, is smaller than the numerator. An example of this could be, say, 5/4. So our numerator, the top number, is now the larger one. And finally, a mixed number then is just a whole number and a fraction put together. A whole number, I'm just going to write the number sign, a whole number and a fraction. An example here could be 1 is the whole number and 2/3 is the fraction. So you need to know the difference between the three of these definitions, and we also need to know how to move back and forth between improper fractions and mixed numbers. So how do we do that then? An improper fraction to a mixed number. 5/2. Well, we can express this as a mixed number. First, how many times does the denominator go into the numerator? We know that 2 times 2 equals 4. That's good. But 2 times 3 is 6. That's too many. So this one doesn't work. We see that 2 goes into 5 2 times. So that will be our whole number. This should say 1 is left over from the 4. So 4, then we count 1 time up to 5. So the 1 is left over, and we keep the denominator the same. So there we go. 5/2 as a mixed number is 2.5. Let's try another example real quick. We have 7/4. 4 goes into 7 1 time, because 4 times 2 is 8. So 4, and then we have 5, 6, 7, 3 left over. Keep the denominator the same. I like to box my answers so we can see it really clearly. So the 7/4 as a mixed number is 1 3/4. All right, so how do we go the other way? Well, this time we need to look at the whole number and the denominator, and we're going to multiply these two numbers together and then add our numerator. So it has here, keep the same denominator, so we're going to keep 2. Multiply the denominator by the whole number, so denominator by the whole number, 2 times 2, then add the numerator. So 2 times 2 is 4, plus 1 is 5 over 2. There we go. Let's try another example. If we have, say, 3 1/4, 3 times 4, plus 1, keep the same denominator, so 12 plus 1 is 13 over 4. There we go. We modeled some of these in class, so I'll just quickly go over them here for you. The first one, we could model 5 out of 6 if we did our triangle blocks. 5 out of 6, and this is a proper fraction. 2 2/3, this is a mixed number. And we could draw this by 2 holes, however you want to, hexagons, trapezoids, and then 2/3 we could either do parallelograms or triangles. This one, 5 over 3, because the numerator is bigger, we know this is an improper fraction. And so we need to change this to a mixed number before we can model it. So 3 goes into 5 one time with 2 left over, keep the same denominator, 1 2/3. 1 and a 6, again, we could do it however we want, as long as we show the whole hexagon. And then 1/6 is a little triangle. This is a mixed number. And a half, we could show, say, a trapezoid. And this is a proper fraction because the numerator is smaller than the denominator. Last but not least, we have another improper fraction, so we need to change this as well to a mixed number. 2 goes into 3 once, with 1 left over, keep the same denominator. Oopsies. It's not going to be a very good hexagon. Here we go. 1 1/2. Wonderful. So now you are comfortable with our introduction on fractions. We'll see you for lesson 6.0b on adding and subtracting.